Hello everybody, this is episode 8 of the Qiskit Developer Preparation series presented to you by QuantumGrad. I am Abhanaik and today we will be solving question 8 of the Pearson Sample test. Let us begin by first knowing the versions of Qiskit and the various libraries contained within it by using the command lines used in cell 1 and cell 2. Now that we know our version, let us understand our question. This is question number 8 from the Pearson Sample test, which reads as follows. Which two code fragments, when inserted into the code below, will produce the state vector shown in the output? And you have been provided with the code, and this is the output. So you have to tell which of the options, when inserted in this place, that is the insert fragment here part, will provide us with this particular output. This is what our desired state vector looks like. So to begin with solving the options, let us first import the required packages. Here, as you can see, I have already imported them. Here you will require from Qiskit, import the quantum circuit, quantum register, classical register, air and execute, and from Qiskit visualization we'll import all the desired functions, and from math we are importing square root. Now there are various ways in order to obtain this particular vector. So this can be done by either generating a bell pair, or it can be done by initializing the two qubits with the entangled states 0, 0 and 1, 1. Let us go through our options for further clarification. So this is our option A. So here we are initializing the qubits to a specific state directly. Okay. Using the initialize method, we can directly assign or initialize the desired state vector to the system. Here we first need to assign a list to our desired state variable, here v, and then we use the initialize method. The parameters of the method are the state in a list form and the list of qubits over which the state will be applied. This is what our circuit will look like. There are two qubits and a state has been initialized over the two of them. Now we need to obtain the state vector, and we do this with the help of Air's state vector simulator using the getBackend method. Run the job using execute, but you can also do that by using the run method. Once we have our results, use the getStateVector method to retrieve your state vector, and then press shift plus enter, and you will have your state vector in this text form. You can also retrieve it in the latex form by using this command, or you can use the array_toLatex method, and this is our result. Now let us consider option B. As we know, we can also prepare our state vector using the bell states. So let us try doing so. So this is the circuit which will prepare the bell state. Using the code as used in the previous example, we can retrieve our state vector, and this is what the state vector will look like in the latex form. As you can see, this state vector is the same as the desired state vector. Therefore, option B is also the correct answer along with option A. Let us see option C. Here we are initializing both the qubits separately. Let us see what a resultant state vector looks like. This is our circuit and this is our state vector. As you can see, this is a state of 0, 1 and not a required state vector. This is the same if we apply the X gate to qubit 0, which can be seen in this example. As you can see, apply the X gate on the first qubit will provide us with a state vector which will be equal to the state vector which will be obtained by initializing both the qubits in the given states. Let us explore option D. Here we have just a C0 with the control bit being qubit 0 and the target bit being qubit 1. And this is our circuit. Let us see our state vector for the given circuit, which as you can see is 0, 0. This is because our control bit is in the state 0. Now let's talk about option E. Now let us have a state where we apply the Hadamard gate to both the qubits, and this is our circuit. Let us see what our state vector looks like. This is our state vector, which as you can see is a superposition of all the states. Therefore, we can conclude that option A and B are the right options. You can take both of them and move ahead. If you found the video helpful, do like it. If you have any doubts, put them in the comment section below and subscribe to QuantumGrad for more such videos.